Hello, what's up, everybody? This is Papa Bale. How's it hanging? This is Papa Bale. Welcome to the channel. Hmm. So yeah, I'm gonna be involved today. I've decided to mod my own channel for a while. You're gonna see what I'm all about. Monopolar amp funnel pulse motor AC version. So what I mean by AC version is it starts out as DC, but once it passes that first coil, it's going to begin to oscillate between the coils unless you put a DC rectifier in between them. That is not a symbol for a DC rectifier. It's just the direction in which they're all hooked up in series, all the coils to the ground. It's a pretty simple diagram. Over here we got a painting that I did about a year ago. It's pretty neat. Got my 3D printer. It's trusty. I lost my clip. I think I found it, but it popped off and I couldn't find it, so I electrical taped. It works sometimes, it doesn't work other times, but it usually rebounds pretty good. Here I am charging my 12-volt battery pack. Got two of those on my counter rotating pulse motor here. So virtually what this does is the stator spins one way and the rotor, which is this one right here, spins the other way. It's pretty neat. We're doing a 2 amp dump into the battery. So I'm not sure exactly how often that happens, but when that light turns green, should be good. Hello, hello. Sorry, I would have pinned a comment about what's going on, but I'm pretty ignorant actually on how to do all this stuff. I had some issues, but I'm learning. Hello, hello. Counter rotating DC. This is a DC version of counter rotating pulse motor. I mean, most of them I believe are AC, at least all the working versions of one. There's another one that I really like to see that uses an AC configuration of coils. This right here, this junk. Tom, this is a counter rotating DC pulse motor. These are wedge shaped coils, 250 turns of 20 gauge apiece. Right now I'm currently charging the battery pack. It's completely untethered, man. This thing will spin both ways for a while. I got several rotors that I can use with the stator. This is a stator for a pulse motor. So there's a lot of different ways I could describe it, but it is a stator. Nah, man, this one looks more like the flux capacitor over here. But yeah, the 120-degree theme is common in the flux capacitor theme as well. They kind of align. I understand what you mean. The boom. Thank you. I don't know if that's a token of support or. Here comes the boom, ready or not. I got my little Neo, about 1.25 inch mag right there. What I was thinking about doing with that is with this setup over here, since these are really ended up being quite powerful magnets, electromagnets. They're only 2 layers of 20 gauge wrapped around a solid soft iron core. But putting the Neo like right here in the middle, so it's affected by all 3, and then having it on a different, to put it on XYZ. So have the 120s, but on XYZ instead of just X. At least XYZ. I mean, you could do so many different combinations, but I think XYZ is a good place to start and see what happens. Encase it, enclose it in, just like a chassis designed for it. See how fast we can get that thing going just on a reed switch. All right, that one battery is charged up. If you can see, the light is green. I'm going to switch batteries now and charge up the other one. I am so happy that we are keeping it real today that you can't possibly understand. All right. Sorry about that. I had to do that with one hand, but I got it done and we're charging. You want to fly? That's cool. I have, I won't make it fly, but it might push some wind if the shaft spun. The shaft doesn't spin though, so. Yeah, no, not gonna fly today, I don't think. That'd be cool though. But I mean, the idea that I have is to get all of this into something that I can spin like a top that might be, that big altogether. 3.5 inches max on the diameter. Maybe even have a little solar panel on the top, little round solar panel. I'm thinking just like a big round top or a dreidel-like structure. This is more of a squarish. Yeah, I would hook it up right now, but well, I'll put it in. I'm going to transfer this to the tripod, but I am going to pick this back up. I want to keep things tight today on the channel in regards to what we're talking about. So bear with me just for a second. Now we just got to charge that up. That last little bit of battery here just needs to charge up real quick. So I have another variation of a stator here that the shaft does spin. So you spin the shaft. This is way too big, but you get the point. And then the stator spins, and the rotor will spin in the opposite direction, and it should increase in speed the longer it spins for, at a constant rate of power. You don't really have to increase the power with this one. I have it hooked up backwards, basically. I put the power into the coil first, and it works both ways, but I think the suggestion is that I'm blowing my stuff a lot faster because it's coming out AC and it's not being rectified. So if it just comes out of the power source DC straight to the transistor, it's going to work better. Is what it was laid out to me as, and I think that's sound advice. And I'm probably going to try and flip this. Maybe just run it on one battery instead of two. That might be cool. All right, so this is actually going to take some time to sort out, just a little bit of time. Okay, so this is the positive. So we're going to take the emitter of the transistor, and we're going to plug it into the beginning of the coil just to start off here by switching that around. Oh, man. See, working with the jumpers and these connectors is a crapshoot. Kinda. Works most of the time. All right, that should be good. think this is getting fried. It's definitely melting with the 24 volts going through. I hope that didn't. All right, so that's hooked up. So now the power, and this is where it's gonna, you know, if I have to take it all apart, then that's okay. Or unglue all this stuff, basically, is what I gotta do. Maybe. So it comes in through this clip right here. So in order, the red power, we're going to try and do something about that. But the battery's got to go in right here. Yeah. Man, that's what you get when you do this stuff backwards. So we'll start from the battery, actually, because this has got to go into, and we'll leave that the way it is, and we'll just make a whole new jumper wire connection here. Hopefully this is a good one. Yeah, it's a good one. I was instructed, kind of, that it won't heat up as fast if I hook it up this way. So that's what I'm doing. Okay, and now I think we're good. I hope we're good. I just got to plug the red wire into that clip and we should be good. But where's it dump? That's what I'm getting at right now. It's kind of a waste of a clip. Yeah, I'm trying to make the transistor last longer. Not get so hot. So I think All right, I think I'm gonna run it in series anyway. One second, I gotta take this. Good stuff to have. Insurance of all different kinds. Okay, we're still charging here. I want to get this circuit right the first time. So we're going to start from the beginning. And the beginning is the red wire of the battery. That's the beginning of the circuit. Positive battery connection. That's going to go to the collector. Then the emitter is going to go into the coils. And then it's going to come out the other end of the coils, and it's going to go into the black wire of the second battery. Cool, cool. Yeah, well, life happens when you least expect it to. Yeah, it's weird. I don't know. I feel like I'm combating myself, you know, a lot of the time when I go through, you know, like that phone call. There's nothing I could have done about it, really. Only took 5 minutes. Nice and quick. All right, so just waiting on the charge here to get done. That was really awkward, though. I don't like having to use my phone for the video at all. I don't like using my phone for the video. So I'm going to set up a wide angle camera from the top here. It's going to go down. Wow. Interesting. So the charge rate is the same. What I'm trying to find actually is some SLA batteries that are about the same size as these ones right here. Get those on here, hook this up with some 2 SG generator circuitry. See how long we can spin it for. Hey Mike, if you want to be a mod again, we're going to have to talk. After last night, I kind of hit the reset button. And we're going to go from there. We can renegotiate everything and it's cool and I can hook you back up. But, you know, obviously I need help. A little bit of help doing this. And it wasn't fair what happened last night to my moderators. Seriously, if you have a name that I can't say out loud on my channel, you're gone automatically. I don't care what your philosophies are or anything, you're out. We're in society of high sciences. I love it. I get high all the time. Seriously, man, if I can't say your name out loud on my channel, you don't need to be here. You do not need to be here. It has nothing to do with the color of your skin. See, and that's how easy that is. Seriously, man, any of these people, they're gone. Okay? And then if you got their back, you're gone too. Simple. I don't have a sense of humor today, guys. I just don't have a sense of humor today. So bring it on. Let's go. You know, there's YouTube guidelines, there's civil rights, and then there's my rules. Okay? And this channel doesn't have anything to do with racism or civil rights, so leave it out. This just doesn't belong here. I'm making it clear. Hopefully, it won't happen again, and probably will. But there are going to be some automatic bans happening for certain words used on my channel. And that should have happened a long time ago. These people that get through, I don't even know how they get their names made to begin with, how the account is allowed to perpetuate itself at all. I don't understand that. That's a hiccup in the system. It's not about civil rights, man. Yes, sir. I just, I had to make myself heard. I'm just common sense in my mind. Well, we got a counter rotating pulse motor right here that's charged. I'm charging the batteries right now currently with the battery charger over there for the DC metal halide, nickel metal halide batteries that I got. Correct. Yeah. And I'm happy. I'm happy that things are going well today. Thank you for keeping me on track. I really appreciate it. So, yeah, in regards to electronics, we're going to try and hook the circuit. Usually, all right, this is what my problem, I believe, has been since the beginning. I hooked the circuit up coil first. So by the time it gets to the transistor, it's kind of AC, DC, maybe. So we're going to try hooking it straight into the transistor and having it come out the coils back into the batteries. We're going to hook it up the other way, the way that I wasn't taught how to do it. No, it's okay. It's all right. I seriously, man. I'm not. It's not about the BS or engaging in the BS. It's about not engaging in the BS and what's absolutely going to happen. You know. So I don't have to look at it either. That's my point. Robot, I really appreciate you, bro, but I don't know about your name. Are you Russian? Robot? Okay, man, I don't know about your name. I've just learned recently that that might mean, counterproductive word in my language. It's not about that. It's about what the word means in Russian. um, of course. Terminator all the way, bro. You gotta, I don't know. Something's gotta, I don't even know what to think right now. You're cool though. Um, I appreciate you. All right, so we're gonna flip the circuitry and hopefully the transistor won't fry. And that's the whole point of doing it that way, is so that the DC electricity goes directly into the transistor and isn't kind of oscillated and flip-flopped around by the time it actually gets to the transistor by the way that I was doing it. How you doing, Peter? You're good, man. You're good, bro. Thanks for coming. I really appreciate you hanging out still, man. I really like that. But this is per your request, man. I just trying to do what's right here. I know yesterday was a hard day for mods. And I don't blame you for wanting to go, dude. So if you want to join back up, man, hit me up on the Discord after this stream and we can hook it back up. I might even be able to do it right now if you're, but yeah, if you really need to take a break, man, it's all good. However long you need, bro. What's up, Noah? All right, Noah. I just got done explaining about people rubbing me the wrong way, dude. So if I gotta get something off my chest, I'm gonna have to do that. And we didn't talk about anything, dude. Not really. I mean, you no, man. There's nothing like that gonna be going on, dude. Seriously. I don't even know how to handle all this stuff except to give people what they ask for. So yeah. Um, so about that probe and putting it in the hole, it was in the wrong hole because we did the math and the math came out wrong. So we knew we put it in the wrong hole because the math came out wrong. Um, so we'll try the other hole after this. We're just gonna try all the holes, okay? That's how we're gonna play it out. Hell yeah, man. The content is awesome. I really appreciate the content, and I will stick with the content. It's great advice from both, the channel and Noah. Now that I said what I got to say, and the rules have been defined, they're pretty, like, in the intro. You go down, the rules of my channel are really simple. There are 3 rules. Don't be a dick. If you think it's a dick move, don't do it, because it's a dick move. And then rule number 3 is refer to rule number 1. Don't be a dick. Awesome rules, man. Rules to live by. I really appreciate positive feedback, and I'm listening to you now. Thank you. 3 simple rules, man, and really the 3rd rule is the first rule. And the reason it's named Adult Swim today is because typically I just expect all adults to know these rules. So, yeah, I don't know why this battery is taking so long to charge. Maybe we can move on without it charging. All the way, I mean. Well, it must have been drained pretty hard. Yep, 3 rules. 1, don't be a dick. 2, if you think it's a dick move, don't do it, because it's probably a dick move. And then rule number 3, refer to rule number 1. And yeah, when we're in an intermediate phase of the content, I tend to get off track, and I apologize. 100%, it is my bad. We're going to move forward. I'm going to put this in a tripod. Yes, please pin any comments that are related to content. Noah, that's perfect. All right, so that's the beginning. So go around. So right there. see if we can get this all the way around. So this is the one that's got to go in there. All right, we're good. Just had to flap that off real quick. That was close. Right. All right, now I gotta reverse this all in my mind to make sure I got it right before I turn it on. All right, so from here, that doesn't look right at all. Maybe this is why, because it didn't do it right. Okay, so collector, this battery goes to the collector. So in series to this one don't. All right, that looks better. Maybe I'll just use the positive strip here for the battery input. Now I just need this jumper wire over here. And the link the collector. I hope it works. That would be awesome. To the power strip. All right. Now the power goes to the collector, the base is triggered. We'll see if the base is working in just a second. That's what's really going to tell the tale here. Something's not right. Oh, what a surprise. Okay, so we'll take out that extra connection. We'll put this back in here like this. Is that in the right slot? Yes. So emitter goes to the beginning of the 20, and then it ends. Just making sure I got the ends right. Right here. All right, so we tried doing something new. I've obviously got something not right here. That's not getting hot, so that was the whole point of that. Oh, duh. That might be it right there. All right, I think we're golden. Oh, duh. Man, I'm excited now. Totally forgot about this. And it looks like that popped out. So that'll go in there like that. And then this dust to go in this hole. Man, this is ridiculous trying to do this on the fly. All right, so what am I missing? Maybe I got it reversed, but if it's reversed, I can't hook it up that way at all. I have to revamp like the whole thing. Let's make sure all this stuff is plugged in correctly. Yeah, okay. But that's the end of it. That's not the start of it. I have a feeling it'd be something crazy in the end, and it's not. It's never really that easy. All right, I hope that's good. I really do. Because if you plug it in too far, then that little rubber thing around the end there prevents a connection. Wow. Okay. What's going on, man? This won't clip for some reason. There we go. Is that it? Did I get it? We'll see in a second. Nope. I'm going to have to build that from the start. Let's see if I can even put it back the way it was. So we'll unhook. We'll do that later. Because I do want to kind of see if this thing will still. All right. So when the emitter is connected to the ground, it looks like everything kind of works. That's my hypothesis. And I gotta like do it all. I don't even know where the problem is, you know. One you can like fly in. Wow, it's getting hot. I'm gonna have to turn on this fan. So next time we see this, it'll be connected in a different way. Because I think, wait a minute, before I give up on this, we're going to connect to this breadboard with the emitter, and then I'm going to connect, but I'm going to connect to the collector to this emitter. Wow, I'm sweating pretty bad. So this is a 26 gauge wire that I'm just shoving in here. We poke a hole in that one first. We'll just do one battery. This is going to be the negative. Here. It's still the negative though. Oh man. So positive goes in here, and then this jumper wire connects to the collector. Like that. I hope that's deep enough in there. That should be deep enough. But I kind of have some trouble with these. If the tip gets bent, it doesn't go in all the way. Alright. We'll unhook. We'll leave that the way it is for now. yet. Ugh. I was so sure that I had it that time because it was simpler. Something's not happening here. So, real fast, take that out, put that back in the negative dump because it makes sense. Take this out. Disconnect that. It's probably just because I tried to go over the breadboard halfway point here. It doesn't always work. So this will go into the collector. Unhook this. We're going to just start straight up from the beginning, which is this one right here. Oh. So it'll go around, it'll dump into the collector. Hopefully nothing crazy like a reed switch blowing happened, because that'll just set me back even more. But we're nearly there, back to the way it was, I hope. I hope, and I quote. Just go in here like so. And this will ground. Alright. Turn that off. Oh, that's such a... I keep on doing that because I'm getting more and more exhausted every time I try and do this. But it should work now. Wham! There it goes. Finally. this light is hot. So anybody got a design for remote control? Or do I gotta jack one up in RC? I can do that. I hope. Because it'd be nice to be able to stop it. A little on-off switch that I can just hold in my hand. That'd be cool. I don't know why it doesn't. It's got to be the way I hooked it up, but we're gonna get it figured out, and we're gonna have it hooked up the other way because that's hot. The transistor is hot right now. It's not supposed to be hot. I mean, it is pushing 24 volts right now instead of 12, but still should be able to handle it based on the specs for the transistor. But I think honestly it's going to be maybe 2 rechargeable 9-volt batteries in here for like an 18-volt thing instead of 24-volt. But that's pretty awesome. Yeah, hell yeah. If you heard Mike, you're absolutely right, man. Walking around for 3 hours, just standing here, it's hard sometimes. I'm going to get my PC over here on this side. I'm going to get the aerial view wide angle hooked up. We're going to do some pretty cool stuff in the future here. Just have it dangling up there from the ceiling. Maybe not dangling, it'll be supported somehow. Alright, I do not know how much battery I have left. Huh. Yes. A USB wide angle lens from detached from the ceiling. So like right up there, looking straight down. And then maybe one angle from the side and then one from the long view. Like either this way or the other way. Like so. So people, like, I don't have to carry it. If I need to use my hands, I can, kind of thing. Well, yeah, the stream time isn't what I'm looking. Well, I guess I can kind of do the math. So I'm thinking I might have 20% left on my battery. Yeah, get a really close angle view of like stuff like that. And then sit down. Heck yeah, man. Oh, sweet. But like this rotor right here, this gray one on the end, is one of the most versatile rotors I've ever built. Honestly. Because of the cube magnets, I got 3 setups that I can just, all I got to do is flip the orientation of the magnets, and it's awesome. So these are now north facing downward. For an axial flux. And it works. They're, interchangeable. This one goes at about half the speed though because of the position of the magnets and the strength. But the coils saturate a lot less quickly with this one. Heck yeah, man. Just give it a freaking minute. Just watch it spin. It's great. No, Bo, I haven't. Have you? No, that's good, Noah. That's way off topic. So thank you. So about, see, that's at 24 volts. It's only going like 400 RPMs. So that might even be not good for it. If it's not switching fast enough this way. I might put a diode across the emitter and collector so I can catch the spike when the coil collapses. Because I think even though we're not using a trigger coil, you're still going to get some sort of spike when the coil shuts off, right? And that might straighten out a little bit the oscillation that's happening in the coils here before it actually hits the transistor. Having a diode there. Or it might turn into an AC-DC formation. Yeah. Well, that's the only one I really knew about, was that the trigger coil needs a resistor to the base for that purpose. Oh, yeah. I get what you're saying. Just from the magnetic induced voltage and current. That's all I used to work with was magnetic induced voltage and current. So basically, when a magnet passes a coil that's designed to collect its energy, it'll generate voltage and amperage. Now, whether or not that's motor ready is left to be determined, but electricity wattage is being generated from this coil because a magnet passed by it. It collapses, has all that characteristic every time a magnet passes. At least that's what I'm gathering from what Mike is telling me right now. And that makes it a whole lot more tricky to keep everything going. But this rotor, awesome, so cool, very powerful. Oh yeah, I got a lot. It's got some things to do here. So, like, making it DC before it actually hits the transistor might be beneficial. All right, I'm gonna put it back on the tripod. Thanks for being cool, people. All right. Boom. So the ultimate objective, I believe, is to get it reversed so that I can send the electricity from the battery straight to the transistor first, and it'll run on pure DC, and in that fashion, I believe it'll run as fast as it does on 24 with a 12 volt battery only. I believe there's a lot more speed involved in having it hooked up the other way. That's why I tried to do it. See how easy that works though now? I mean, if I figure out exactly how to hook it up the other way, I'll probably be just as easy. So I made some adjustments to the shaft. I got it clamped down underneath the table now too, so it's a lot more sturdy. About 800 RPMs. No, 29, 23. It's too hard to read that. There's too many different variations. It probably needs a new battery. And that's kind of dangerous, stopping it that way, but you gotta break the connection somehow. I mean, I could just stop the rotor, but the stator would continue to spin. There's lots of ways I could do it. Yes, Mike. Let me show you my my other variation of the same mechanism or the same system, basically. So this one, the shaft is part of the whole thing, and the commutator is hooked to the shaft. But that one won't do that. The one that's in the center of the table is not going to do that. But I can switch it out for this one. And then I'd have to make more coils or switch the coils over to this stator. So, yeah, the reason that I'm not using the shaft is because it would automatically tether everything to use the shaft in this variation. But like I said, we got Big Uncle over here. Big Unc does pretty much the same thing. And I'm definitely going to be working with the moving shaft in the future. The stator's got to be hooked to the shaft in the little one that I want to make. So you can spin it like a top. That's the whole point of that. Oh yeah, that's still humming. Even though it's disconnected, it is still humming. I don't know why it does that. I think it's because it's more voltage than it's designed to handle. I mean, the breadboard holes are getting kind of mel-shaping. And you're right, the wattage would be the same. So the same thing would be occurring due to ampage if I were to hook these batteries up in parallel. Except I really don't think these switches are designed to handle amps. Might be totally wrong. I might be hooking these up in parallel wrong. That's totally possible too. I've been using these connectors to do it. You know, hook both ends of both red in here, and then have it come out one. And then hook both blue negative in here and have it come out one. Hook it to the breadboard. You know, keep it simple. But it might have to be individually done. And that's just for the battery connection. It's not a transistor connection or a coil connection. It's just for the batteries. To either get the capacitance or the voltage to increase. Right now we're working with more voltage. It's the closest I've gotten one to spin, for them both to spin at roughly, you know, the rate at which the top and the bottom spin is different. Okay, so this is the closest they've been to being in sync thusly. You know, I've got this variation of this is axial flux. I got this variation. This is radial flux. The reed switch, it's basically the same thing, just radial flux. Runs on a lot more electricity though, because it runs on a commutator ring. I'll lift it up and you can see that. So you got two brushes hanging down, one for the positive ring here, and one for the negative ring in the middle. It's virtually 95 to 100% duty cycle. It runs the reed switch, and the coils are timed by the reed switch. So basically the power's always on, and it just pulses with the switch. Ooh. Now, a combination of things to make this work would be this 12-volt battery, one of these, buck boost converter, transformer. This is definitely a transformer style boost converter. It's beyond comprehension a transformer. It works the same way. You gotta screw it to change the voltage, you know? But it's DC. It's DC to DC, so it's not your typical transformer, which is AC. was a buck boost converter. But I looked it up under transformers, so whatever. Anyway, that'll turn the 12 volts and amps into whatever voltage I want, basically up to 345 volts of DC. Plug it in the positive and negative of this thing, and that'll make the table like turn over because it's not properly balanced. It's really just a straight direct connection, positive and negative. Really simple, no transistor involved in that one. That's probably why the power consumption is so high. But it goes pretty fast. It's pretty smooth. Might battery operate that one as well. And in that case, I can upgrade it with the transistor. Alright, so let's just discuss one of my other hobbies real quick. That's art. I painted that about a year ago. That's my, depiction of the Tryst by the Dead Sea, the cave of the Dead Sea Scrolls. That's what this is right here. This is an acrylic. It might look like a watercolor to some people, but it's definitely acrylic. Got my initials down there on the bottom, M.P.H. I just like to, throw some paint on a canvas. I put a time limit on everything that I do, pretty much. If it doesn't fit in the SMART goal, it doesn't need to be done at that time. I got some schematics here, just diagrams. This is a 3-phase motor. You got one drive 120, and then you got two generator 120s that are separate, but they can be linked in series. There's lots of things you can do with this. The whole engine here is built on 32 gauge coils. It's pretty neat. We got similar one, except the 6 drive coils aren't in separate 120s. They're in one series circuit of AC connection. So you hook your either your light bulb or your bridge rectifier up right here. You got your switch. Basically just a frickin', it's a motor with the 120 drive circuit and at 40 degrees of separation there are 9 magnets here. You can just, at each magnet you put a coil. 6 of them to generate, 3 of them to drive your motor. This is a diagram of the hodgepodge amp funnel. We got every coil here is different gauge, different size. But basically it starts off real thick at 14 gauge and it ends at 32 gauge. It's pretty neat. It goes about 1600 RPM solid with just a reed switch. Pretty cool. But here's a question for you. The question is, how do bottlenecks work in electronics, man. As soon as the bottleneck is introduced into the circuit, or does the electricity actually have to bump into the bottleneck for it to be recognized? And I think it's both because of how fast it all really happens. But I don't think the bottleneck aspect of the whole amp funnel really works the way I think it does. You know, I thought, you started off with a high amp draw and you ended up with a low amp draw because it kept on bottlenecking down. And every time it would bottleneck, you get a little burst of whatever happens when that happens. But really all it ended up doing was being a 32 gauge wire through the whole thing. That's what ended up happening. And the 32 gauge spot got really hot. So, I don't know, honestly, if that's what I felt happened. That, there wasn't that extra oomph from the bottlenecking. It was just, but that, it wouldn't have gotten so hot just on the end if that's the truth. The whole thing would have been the same amount of heat if what I just said was actually what happened. It's so hard to see clearly because there's no way to really test it. You'd have to hook a multimeter up to each coil and then one up to the whole series. You'd have to hook up like 8 multimeters to get an accurate reading on the amp funnel. But it's cool. It moves, it works. It's just not really measurable. It's not something you can replicate. Even though I tried to write it down, and who would replicate that anyway? You know what I'm saying? It's just an experiment, a toy. It's not meant to be done again. But I wrote it down anyway, because I thought it was pretty cool. Anyway, I think my battery is going to die pretty soon. Oh, I'm sorry. I'm sorry. I hope everybody's being cool. Sounds good. Whoever's back, robot, welcome back. Wow, that was a new sound for me. That's cool. And until I get my remote control built, or defunctionized, or however I'm going to do it, I'm probably just going to buy like an RC truck or something. Take out the mechanism in the truck, and have the mechanism from the remote. And it might balance out the weight a little bit more on this if I just put it right here in the breadboard. Because you got the 3 coils, and then you got the 2 heavy batteries, and then you got the light breadboard. If I could put something else right there, that might balance it out enough to go even faster than it's going. Because there is a small amount of friction from the weight disparity. Differential. Whatever you want to call it. Got these heat sinks, but like I was explaining earlier, the end size screws that came with these are not long enough. So I got one screw that's long enough, and I bought it with my SG circuits. Thank you very much. The screw is so, it's more than a blessing. And it's compatible with all of them and it works, but I gotta take the screw out until I buy longer screws. It's about half as long as it needs to be. Alright. About 13, 14 years ago, I painted this. I didn't know what it was at the time, but I think it's a motor. Honestly, and there's lots of triangles involved with this, but I think it's a motor because it's spinning. Whatever it is, it's spinning, and I think I don't know, but yeah, I was really messed up. It was like a trance thing, you know, and I just painted, and it was very therapeutic, but I think that's a motor, honestly, or an Utron. Let me show you. It's essentially one of these. It's a square when you look at it one way, and a circle when you look at it the other way. But it's really, if you put it up on its, a triangle as well, like two triangles slapped together, it's two cones. But from a two-dimensional standpoint, it could definitely be. Anyway, this always intrigued me because I had no idea what it was, and I painted it, so it really kind of freaked me out. At the same time, it was pretty cool. Thanks, Militant Roots. Appreciate that. Sorry if I'm not keeping up. Yeah, Mike's got some awesome music on his channel. It's really good for the mind. Man, I wish I could have got that other way hooked up right. That would have been neat. I'll do it offline, and I'll make sure that it's right, and then the next time I come live, we'll get to look at it. We'll get to see the differences, and the differences in temperature, the transistor, and everything. It's like having a hot bed on a printer that doesn't heat evenly. You never know what's wrong. It's like, why isn't it sticking? Why isn't it adhering? And it's like, well, half of it's this temperature and the other half is this temperature. Something's not working correctly. So, nipping things in the bud, so to say. I guess we'll get another look at this real quick. But yeah, without a chair to sit down on, I really gotta either start walking or I gotta move around. Wow, man, I've never had this much trouble with the hole before. There we go. I'm actually feeling some resistance there. Like an opposing magnetic force. We're about 2,800 right now. Still increasing at a pretty hot clip. 29, 3,000. That's 1,000 RPMs right there. Whoo, whoo, whoo. Probably should have grabbed and put a little bit more force into that so it didn't rub my fingers off. Alright, well, that's cool. I like it when we keep it simple, guys. This is awesome. What's up, Mr. Livingston? It's a kind of rotating DC axial flux pulse motor. It's basically a toy, because that's all it's really good for. You can't really measure anything on this, because that would tether it down. Unless you can do it with a remote control, and those readings will be good. And this is pretty much what we've been playing with all day. It's pretty fun. You got a combination of a reed switch for timing. It's about 15, maybe a little less than 15 degrees offset from the coil. Alright, that's still hot. Gotcha. Bluetooth mic. Let me see about this real quick. Having trouble hearing me? Alright. Just put this in. All right, I believe we're back, and I hope can you hear me good? Am I too loud now? Make sure that green light is on. Yep, we're good. Sweet. Thank you. All right. If it's rubbing against my shirt, I apologize. Oh, good. Thank God. All right, now that I can calm down a little bit. Oh, it is. Maybe if I see, this is where I can clip it to my. I'll just put it on the table. How about that? All right, is that better? Can't pocket, you say. All right, I hope my shirt doesn't rub against that too much. How's that? Maybe I could tuck it in. That would help. All right, cool. All right, so let's see if the transistor is cooled off. Oh, yeah, it's good. There's glue on the table. That's not good. Because that is going to stink. Oh, man. All right. There's one way to get the glue off. There's more than one way to get the glue off. I bumped into it. No, I'm not an engineer. Um, I wouldn't even know how to rate myself as a person who knows how to build stuff. All I know is I had a will, and where there's a will, there's a way. Whether or not it's the correct way, I don't know for certain. And yeah, to some people there is a right way to do this stuff. I would say like if you're building the pyramids, something like that, there's definitely a lot on the line there. So yeah, in some instances there's a right and a wrong way to do this stuff. But I've gotten along pretty good. And I still don't know if I'm doing it right. Yeah, my hand is like clipping that mic. I can feel it. And it's perfect position. So if you get a muffled sound, I apologize. So do you think cannibalizing an RC vehicle will yield fruit for this? All right, how's that? That's got to be good. So, yeah, I don't think this is going to work without like at least a signal generator. Oh no, doesn't look like it's even going to go on. I don't want this stuff. Probably really stuff. Mm-hmm. That's not going to go on, unfortunately. A lot of these things are just microns off on whether they're going to fit or not. That one does not fit the shaft. Need a very slightly smaller shaft, or need to file it down again on the tip here so it'll slide on. Not a time machine doesn't move anywhere near that fast, but it might be reminiscent of a flux capacitor, maybe. I mean, it is a 120-degree design. And then there's another guy out there that made, kind of rotating, basically crap. Just to be related to that as well. That's 24 volts. I'm going to reiterate again. I'm looking for a design for remote control so that I can turn it off until I get that. That's how you turn it off. Disengage the switch. Dominate the world again. I like how you put that. Like this has all been done before. We're just going to do it again. Sorry. I'll pull my pants up. All right. So we'll take a look at this other rotor real quick. The big magnet rotor runs very well with this machine now. I'm not going to get anywhere near the RPM. I believe it's keep the magnet's position up the bus. What I mean by that, this coil is a wedge shape all the way to the center hole. And these magnets are all the way at the end, so they're only hitting this end part, coil. So you're not getting anywhere near the amount of thrust you're getting with these bigger magnets that cover more of the coil. Doesn't mean you're not getting anything at all. You see that momentarily. Oh. Well, not entirely not absent-minded. I get absent-minded. And I've taken apart the entire thing. I really need to do is plug it in a different hole. But I figured that. Okay, we're live. All right, ladies and gentlemen. There we go. Haha. Thank you. I really appreciate everybody hanging around for me to close this out. And we're going to check the heat. That's been running the whole time. So, wow, that's pretty hot. Take that out of there. Hello, Rye. What's up? All right, but my phone is literally dead. So good night, ladies and gentlemen. Peace out. Have a wonderful day.